Okay, so this is the second lesson in Unit 9, which is creating and recognizing major and minor arcs, central angles, and their measure. So really quickly, there's a ton of vocabulary this lesson. We're going to go over it. We're going to use it the entire unit. So let's start with the simplest one, which is degrees. Degrees are a unit of measure for angles and arcs, so arcs as well. We'll come back to this, but for example, the measure of angle DAH is, so DAH is 80 degrees. Okay, and then let's define central angles, and we'll continue and come back to the degrees. A central angle is an angle formed with the center of the circle as the vertex, and the radii are the legs. So an example of that is this same angle, angle DAH, is a central angle because the vertex is the center of the circle, which is A, and the two radii, right, these segments here, are the legs. And so that's what makes it a central angle. So a central angle is angle DAH, okay? And I didn't put the measure because we're just identifying that this is a central angle. Angle EAI is a central angle. Angle DAE is a central angle, and also technically angle HAI is a central angle. And what I want you to notice is all of them have the vertex A as a letter in the middle, and that's always going to be true for central angles. Okay, now the sum of all of the central angles will always equal 360 degrees. So what I mean by that is this angle here, the measure of angle HAI, plus this angle here, the measure of angle EAI, plus this angle here, the measure of angle DAE, plus this angle here, measure of angle DAH, will always equal 360 degrees. Okay, that'll come in handy when we're solving for a missing angle. Okay, now we're going on to the big vocabulary words: minor arc, major arc, and semicircle. So a minor arc, much like it sounds like, is something that's small. Minor means small. So an arc that has a central angle less than 80 degrees. 180 degrees. So an example of that would be this arc here. This arc here has a central angle that's less than 180 degrees. Now, really quickly, let's talk about arcs. Arcs are when you're traveling along the circle in between 2 points, that is an arc. So this is an example of an arc. This is an example of an arc because it's on the circle in between 2 points. Okay, and the central angle measure, so say for this blue one here, is 80 degrees, and the measure of its intercepted arc is going to be the same. It's going to be congruent. Okay, so if this is 80 degrees, we would say that the measure of its intercepted arc is also 80 degrees. Okay, when we talk about an intercepted arc, you think about these as like hands. Let me do my best to draw a hand. That's one hand. That's another hand, and this is like a person, right? Person with a little smiley face. The intercepted arc is always going to be the arc in between the two arms. Okay, so the intercepted arc and the central angle will always have the same measure. So if this angle here is 30 degrees, then the measure of its intercepted arc is also 30 degrees. Okay? Going back to minor arc, a minor arc is an arc that has a central angle that's less than 180 degrees. So again, this example here, the way that we name it is we say that we can say things like the measure of arc HD is 80 degrees. Okay, and it's a minor arc because it's less than 80 degrees. Okay, we always name it with 2 letters. Another example would be this one here. The measure of arc EI is 30 degrees because it has the same measure as its central angle. A major arc, on the other hand, is an arc that has a central angle that's greater than 180 degrees. Okay, an example of that would be something like this. If I were to go all the way here. Okay. This is an example of a major arc. Let's name it first. We'll always name major arcs using 3 letters. So D, H, I. D, H, I. Now, why can't I name it D, I? You might ask. If I named it DI, I would be naming the minor arc in between, right? This arc is less than 180 degrees. This arc is greater than 180 degrees. Okay, so that's why we don't name it that. It's important to distinguish between the two. DI, and I'll go ahead and put that here. DI would be a minor arc. It is less than 180 degrees. DHI is greater than 180 degrees. Therefore, it's a major arc. We'll go back and find the measure of that after we define a semicircle. A semicircle is an arc that has a central angle that's exactly 180 degrees. And that that semicircle would be this one here, because this angle is 180 degrees. Therefore, this arc is 180 degrees. We will name that using 2 letters. It's fine because it doesn't matter. So the measure of arc HI is 180 degrees. Why does it not matter? Because this is also HI, and it is also 180 degrees. Okay? So let's go back and talk about the pink arc. The pink arc has this as a central angle. It's actually this entire thing. It's made up of the blue arc, the blue angle, and the orange angle. So it will be 80 plus 180, which will be 260 degrees. So the measure of our DHI is 260 degrees, which is greater than 180. We will review this on the next page in the example. Okay, so 3 key relationships we always need to keep in mind, and they're always in them, is one example is vertical angles. We learned that back in Unit 1. When you have 2 intersecting diagonals, they always form vertical angles. And remember, vertical angles are congruent. So those 2 angles are congruent. But also remember that this angle will be congruent to this entire angle, right? So this angle is actually made up of 2, okay? The other piece that you want to keep in mind is supplementary angles. Supplementary angles are 2 angles that add up to equal 180, or multiple angles, I'm sorry. An example of that would be this 60 plus this angle here will equal 180. So the 60-degree angle plus angle ARU will equal 180 degrees. Also, these 3 angles will add up to equal 180, or these 2 angles will add up to equal 180, or these 3 angles will add up to equal 180. The last one is the central angle sum, and that's the fact that all of these angles added together this angle plus this angle plus, I'll do this yellow again, this angle because it's congruent, plus this angle, last but not least, plus this angle will equal 360. So this is 60, this is also 60. Supplementary angles, if this is 60, this is 120. Okay, and the fact that these two combined will be 120 makes this 140. So we know that 60 plus 120 plus 60 plus 80 plus 40 will equal 360 degrees. Okay, so let's do this example together. Example number 1. AT and MU are diameters. It's important to recognize that. AT and MU are diameters. So that tells you where the supplementary angles are. Use the figure to answer the following questions. Before I answer these, I'd like to go ahead and fill them out. So I'm going to use supplementary angles. If this angle is 60 and this angle is on the same diameter, then they add up to equal 180. So 180 minus 60 will give me the 120. Okay? Using vertical angles, I know that these two angles are congruent. So this angle is 60 degrees. And again, I would know that, say, these three angles add up to equal 180. So 180 minus 60 plus 180 is 140. So this will be 40 degrees. Okay, so now let's answer these questions. The measure of angle ARM. ARM, that's this angle here, is 60 degrees. The measure of angle BRU. BRU, so that's this angle here. This angle is the sum of 80 plus 60, which is 140 degrees. The measure of arc AB, and it's a minor arc because it's named with two letters. Arc AB is this arc here. I know that this arc is 60 because its central angle is 60. This arc is 40 because its central angle is 40, making the whole thing 100 degrees. Next is the measure of arc AU. Again, this is a minor arc because it is named with two letters. AU will be the same as its central angle, so it will be 120. Okay. Now the measure of arc ABU. This is a major arc because it's named with three letters. A, B, U. Okay. So ABU is the 60 plus the 40 plus the 80 plus the 60, right? We can add all those up and it will equal that arc. Or if we know the whole thing is 360, this arc will be 360 minus just this piece, which will equal 240 degrees. Kind of cool, right? Okay, last one, MTA, which is a major arc. It's with three letters. MTA. MTA. So it's the 40 plus the 80 plus the 60 plus the 120, or it's 360 minus this piece, right? Because we're not including this piece, it's everything but this piece. So 360 minus 60, which is 300. Okay, go back and rewind if you need to go over that. What type of arc is AUT? AUT. AUT is 120 and 60, so that's 180 degrees. So then that means it is a semicircle. How do you know? Because 120 plus 60 is 180 degrees. Okay. All right, I'm not going to do all of these. I'm going to choose to just do 2 of them. I'm going to do A and C, I think. And you can check the answer key for the other 2. This is just checking your vocabulary. So circle V has a diameter AD and radius VB. Okay, so circle V tells me the center of the circle is V, has a diameter AD. So we have a diameter, that's AD, and radius VB, radius VB. Central angle AVB, AVB measures 60 degrees. Wow, let's go ahead and change that then. This is 60 degrees. Check. C, circle R, so we know the center is R, has diameters EF, EF, and GF. That should be something else, because you can't have 2 different endpoints that have the same one. Okay, let's skip that. I need to fix that. Sorry. How about this one? Circle T has diameters AB and CD. Circle T has diameters AB, AB, and CD. CD. The measure arc AC, this one, is 120. My picture doesn't match, but that's okay. What is the measure of angle ATD? ATD. So if the arc is 120, the central angle is also 120. These 2 angles added together will be 180, so that means that this one is 60 degrees. Okay, check the answer keys to the correction of this one and all your answers for the practice.